So let's just do it a couple more times. We've got equals 0, so we are on the right track. This is exactly what I want. So now let's ask ourselves, when we factor, do we have a GCF? In this case, yes we do. The GCF is a 2. So if I divide a 2 out of everything as well as the 0, then that GCF just comes out and it goes away. Okay? So then I'm left with x squared plus 2x minus 15. 0 divided by 2 is still 0. So now the factoring is much easier. It's just a basic. So let's go off to the side. What multiplies to negative 15? What adds to 2? That is a 5 and 3, and then the 3 is going to be negative, because 5 plus negative 3 is 2. Alright, so that means our factors are x plus 5 and x minus 3. Alright, so that's the factoring. Now the solving is that we split them. X plus 5 could be 0, or x minus 3 could be 0. If either one of those becomes a 0, then when you multiply it, that's why you get 0 for your equation, for your solving. So we just subtract. Subtract 5 from both sides, and we get negative 5. Or we add 3 to both sides, and we get positive 3. Okay? So the solving is just the factors equal 0, and then you solve. Do opposites. Okay? This one looks a little bit different. Let's finish it by setting it up like this, because I don't want that to confuse anyone. So equals 5z minus 4. Now before we solve, we have to get equals 0. Okay, we don't have equals 0 yet. So to do that, we need to subtract the 5z from the 13z, because you want opposites. And then since it's minus 4, you want to add 4 to the 12 so that both of those terms cancel out, because when you do that, you'll finally get equals 0. You really want that 0. It's the only way you can solve these, okay? So when you do that, the z squared comes down. 13 minus 5 is 8z, and 12 plus 4 is 16. So now, random 4. All right, so now we just factor that. Again, this is a basic. What multiplies to 16 and adds to 8? That's 4 and 4. So that's x plus 4 and x plus 4. Well, since it repeats, since it's the same thing over, really you only have to solve one of them. So x plus 4 equals 0. You subtract the 4 over and you get a negative 4. And I already said I call that a double root. So I put dr for double root, so that I recognize that even though there's two factors, that negative 4 works for both factors. It's a double answer. Is really what that phrase double root stands for, okay? So the solving that we're adding is just from here down, where if they're different from each other, each one equals 0 and we solve, or if they're the same, you only have to solve it once, but recognize it's a double root. It stands for two answers, okay?